Okay, so just really quick, I want to apologize for not uploading these videos sooner. Kind of lost track of time this week. That's like completely my fault. But I'm gonna try my best with these videos from here on out to make them shorter and snappier, just to make sure that you guys can get all your information quicker than me rambling. So the first video that I'm going to be doing, I'm actually following the textbook. So if you look at the textbook that I gave you guys a link for, this one, if you open up to the table of contents, you'll see that there are, I don't know if you guys can see it from there, but there are little sections here. I'm going to do a video on each of the sections in here. For chapter 1, I kind of shortened the sections that I did. I kind of abbreviated some of them and abridged some of them because they were really short and some of them aren't really necessary. But this first one I'm going to be doing is on object orientation. So I'm going to be doing this video in multiple parts. The first part is a brief introduction to object orientation. So the abbreviation for object orientation is OOP, and it stands for Object-Oriented Programming or Paradigm. So object-oriented programming or an object-oriented paradigm are very central to C#. And in our case, we have the three pillars of an object-oriented paradigm, which is encapsulation, inheritance, and polymorphism. These later two terms, we don't need to know right now. Those are key, but it's not like, I'm not going to explain them to you guys because it's not going to make sense right now. But we have to understand what encapsulation is, because if you understand what encapsulation is, everything else can kind of come naturally. Encapsulation is basically a protective layer around an object. So the easiest way for me to describe this is to start off with an analogy. So I drew this. This could be like a toy that you find at here, let me swap over to this side. This could be like a toy that you find at Walmart or something. It's got the toy inside. It's got a little description right here. It's got a try me, it's got a price tag, and it's got a button. This is the perfect representation of an object. You can't get to the toy right now. All you can do is it says try me, it's telling you what to do, it's got descriptions, it's got a price tag, and it's got an action you can do to manipulate what's inside without actually touching what's inside. This is the perfect representation of what an object is, and I'm really proud of myself for coming up with this analogy. So if it doesn't make sense, I'm sorry, go ahead and send me a question over on Discord. But the packaging would be the encapsulation. We can do anything that is on the outside of the packaging, right? We can hold it, we can try and bend it, but it's probably not going to work that well. We can push the button, we can read it, and we can look at it. Whereas if we were inside of the packaging, we could actually mess around with the toy itself, and that could be detrimental to the toy. So this is kind of what encapsulation is. Once we start doing examples with it and real world kind of stuff, it'll make a lot more sense. Well, it probably makes sense right now, but it'll be a lot more apparent on why it's important. Okay, I'm going to swap over to the next section now. Okay, so another thing that kind of comes out of object-oriented programming, especially in C#, is something called the unified type system. So before I kind of describe what that is, we need to talk about what a type is. And a type is an encapsulated unit of data. So in C#, you have lots of different types already defined by the compiler. You have integers, you have fractional numbers, you have like strings of characters. You've got a lot. But also user-defined types are a thing as well. I could define a person, or I could define a toilet paper roll, for example. I have control over types as well. And basically all this is the technical definition of encapsulated unit of data. But the informal definition is basically something, it's like a template for something that describes something else. And the UTS, or the Unified Type System, provides a foundation that all of these share in common. So I've got a couple of drawings over here. This one is really simple. You have a circle, and your circle is the foundation. You can add on to that foundation, but you can't take away from it. For example, you can make a triangle, or you can make a rectangle. You can add on to this foundation as much as you want, but you can never take away from it. And this is because of an overarching unified type system. And you can get really complex with how you build on it. You have this foundation, but then you have you could have like a person here. And something else that I didn't draw is that you can change the foundation is almost like guidelines. Basically, this has to be here. Now, it provides a definition for these guidelines as well, or a standard definition. For example, if we had this person, there could be a foundation that says to string, which would basically give me information about this person in a string of characters. And naturally, it would tell me that it is a person object. However, I could redefine it to say the person's name. So the foundation is there to make sure that everything has a consistent base, but then you can change that base or you can add on to it as well. Okay, so this next section of the video is going to be a little technical. It's about classes and interfaces. So basically, we just talked about the unified type system, and I kind of briefly mentioned user-defined types. Classes and interfaces are the user-defined types. They're the main ones of C#. I just made a little bit of a T-chart here to kind of help you guys understand the differences. So in a class, you could say, here is a button. There is a button that does this. Whereas in an interface, you could say, you need a button. That's it. You just need one. I'm not going to tell you what it does. You just need one. In a class, you could say, here's an age. Here's a number that you're going to work with. And in an interface, it could say, you need a number to work with. I'm not going to tell you how you work with it. You just need something to work with. And the main difference is that a class is a template. You have this that does this. You can plug stuff in here, and this will come out. Whereas an interface is a guideline. So interfaces, they can get really messy and really complicated. I haven't used them a whole lot myself yet. I mean, to be fair, I'm only in chapter 4 of the textbook. But I haven't used them a whole lot myself yet. But they're the guideline for the template. So usually you have an interface that defines a class, or that guides a class creation. I'm not going to explain what they're really useful for right now. Just know that they are very useful. And one thing that's kind of complicated, we briefly mentioned inheritance at the beginning of the video. And here's just a brief preview. Classes have limited linear inheritance. Class 2 can inherit class 1. But if I had a third class over here, I should have drawn it, but if I had a third class, it could not inherit class 1. Whereas with an interface, you can inherit it infinite times because it's just a guideline. Class 2 could be like, okay, I want the template that class 1 defines, but I also want to add on to it. This is just like every single template I make is going to use this guideline. So this stuff's really complicated. I don't have a master's degree in this stuff, so I'm having a hard time explaining it. It makes sense in my head, and I only hope that through experience it makes more sense in your guys' heads. Okay, so this one kind of goes into the basis of a template or class. Sorry, not a template. I've been using the word template in this video. That's an analogy. A template is actually something in C# and it's kind of complicated. So I'm not talking about that if you know what that is. I'm talking about a class is analogous to a template, interface analogous to a guideline. Anyways, so I don't really have any drawings to go with this one. This is just kind of like core conceptual understanding. A function, so I'm going to go off defining these and I'm going to explain. A function is a block of predefined code or instructions. This means that I could have a function which finds the average of a list of values. It's just some process that I've streamlined into a single block of code that I can call whenever I want to. They're used all the time in every programming language. A variable is something which has states. That's the best way I can define it without going into examples. And I'm about to go into examples now. Basically, what I mean by states is that, let's say you have an integer. It has different states. It has 1, 2, 3, 4, 5, 6, 7, 8, all the way up to its maximum value in computer programming. That's what I mean by states. Like for a string, you could have hello as one state. You could have hello world as another state. You could have the B movie script as another state. There's just a long list of states. In fact, everything has infinite states except for integers. The change in an I'm skipping ahead here. An event is the change in an object or a variable's state. So event, I'm kind of defining it up here. I actually don't know the real word for this in computer science, so I'm just going to call it an event because that's what C# calls it. It's really useful, especially when you get to threading, because events, like, they kind of watch something. For example, if I had an event watching me and then I changed shirts, it would signal, hey, he changed shirts. That's kind of what an event is, and it's really useful when you're looking to automate things or when you're working with GUIs, because that's how it can, like, watch buttons and stuff. Now let me explain what the title here is saying. Functions in object-oriented languages are methods. What I mean by that is that we have this template, remember? Or in fact, we can go all the way back to the toy analogy that I had drawn right here. The toy, it has a button, and that button is a method. You click that button, and something inside of the toy happens. It could speak, it could dance, it could start World War III. I mean, there's just so much that could happen when you press that button. That's a method. It's just some kind of predefined instruction. Anyways, properties actually don't coincide the variable if you guess that pattern. Properties are kind of a baby. Like, if function and events got married, they would have a baby. But they do also work a lot with variables. So a property can be a variable or it can modify a variable. When I actually start working with code, which will be the next set of videos I do, this will make a lot more sense, but basically it makes it a lot easier to manage getting and setting variable states in a program. It simplifies and streamlines the process using either explicit or implicit code. Something I didn't mention for functions and methods is that they are explicit code. An event, obviously, it just manages it. These are like the core three things that go into a C# class. And if we were to tie it back into interfaces, interfaces would tell you, okay, you need to have a method you need to have a method called this. You need to have a variable called this, or a property called this. And you need to have an event called this. Okay, so this is the last section of this video. I don't really have any images for this one either. This one's really complicated. I dealt with lambda expressions in C++ very rarely. I know that when you start getting to lower level stuff, or when you're getting to super high level stuff or super low level stuff, lambda expressions become a lot more useful. I never actually got to that point. Anyways, the first topic at hand here is that methods can be values. That sounds kind of wrong, but it's not. If you think back to the definition of a method, it is a block of code, like a block of predefined code. And it can be treated like a value. A lot of times, so if you think of just the simple program that I wrote on the board last week, or if you've ever seen any good code like C# code or C++ code, you'll note that functions have parentheses after them, and you can put arguments inside of those parentheses. I actually was going to make a video explaining all this, but I feel like it'd be kind of redundant because you guys would watch it and then you still wouldn't understand. I'm talking about like vocabulary and stuff, so we're just going to learn it by trial and error. But you could put arguments inside of these functions. And doesn't it make sense that you could store these functions in some kind of object? and then use that object somewhere down along the line and pass arguments into it. I know it sounds kind of jank, makes complete sense to me if it sounds jank, but as we get to practicing, we'll start using delegates, which is exactly what this is. That doesn't come for like a couple weeks though, so don't worry. Don't like crap your pants because you don't understand this. It's okay. I didn't either. I had to spend like 3 hours learning it. It's fine. Anyways, lambda expressions are basically the embodiment of value function, like functions as values. But basically, it's crazy. They're wild. It's code that's written on the fly. If you think about a couple videos I made a couple of videos ago, I talked about the compilation and how code is always compiled. That's kind of not true for lambda expressions. Lambda expressions are only created in runtime. The difference is that at compile time, that's when a lot of type checking happens, and I'll explain that in more videos later. But basically, it's where a lot of stuff happens, and runtime is basically say for only run the code. The lambda expressions break that rule. They are created and used whenever they want to be. It's basically shorthand, but they're really kind of useful when you're like, okay, I just want this function to modify stuff inside of this block of code. They're kind of useful. I personally don't really use them a whole lot, so don't worry. I call them stack functions because if I'm not mistaken, they're put on the stack. It's entire blocks of code, huge memory that gets put on the stack. And you guys will understand stack like in like 4 videos maybe. Yeah, I think it's 4 videos. And something that's kind of related to lambda expressions, but also not, is the concept of immutable values. This means that you have variables, which I talked about earlier, that cannot change states. That's actually really useful when you're compiling and writing code that goes everywhere. Like, it's really useful, and you guys will see that in practice more than I could ever explain to you. They're called constants or read-only values. So that's it for this video. If you have any questions, please send them to me on Discord. Like, actually, please use the Discord. I spent some time and made it pretty, and I really want you guys to use it. I know a lot of you guys don't seem like the kind of people to like jump into a Discord, but please use it because that is the best way we can communicate about issues you might be having or questions or concerns. That's all for this video.